Hello, and welcome back to another Math 1000 video. My name is Bo Corkins, and today we are talking about algebra and proportions. So, this is going to be the most base level of algebraic solving, all right, with some applications involved as well. So, a couple basic principles of algebra, the addition principle and the multiplication principle. Right? Adding to both sides, multiplying by both sides. The big thing, don't get too caught up in terminology. Algebra boils down to do the opposite, do it to both sides. That's simple. So notice, all right, I want to solve, I have a few examples here. Solve x plus 7 minus 3. 7 is being added to x, so I'm going to do the opposite, which is subtract 7 from both sides. All right, cancels out on the left side here, and that leaves us with x equals negative 10. Similarly, m minus 9 equals 6. 9 is being subtracted from m, so I'm going to add 9 to both sides. Once again, cancels out on the left side. That leaves m equals 15. Similarly, 56 equals 7t. 7 is being multiplied by t, so I'm going to divide both sides by 7. That gives us 8 on the left side and t on the right side. Now again, 8 equals t. That is equivalent to t equals 8. Okay, those are both correct. It doesn't matter if you write it with the variable on the right side or variable on the left side. The most interesting problems are when we use all these principles together, though. All right. Doing lots of multiplication, addition, subtraction, all of it together. This example here, 2x plus 3 equals 17, this is what we call two-step algebra. It's because you add or subtract a value, then you multiply or divide a value. That's two steps. You do basically the addition principle, then the multiplication principle. Subtract 3 from both sides, and then divide by 2 on both sides. Now, again, should always check your answer. And again, I'm pretty bad at this, but I'll do this one time, right? So if we got x equals 7, that means put that guy back in. 2 times 7 is 14. 14 plus 3, 17. And the whole point is you should get 17 equals 17. All right, the left side is equal to the right side, and that's how you check your answer. Solve 6b minus quantity 3b plus 8 equals 16. This is our big principle here, the rainbow. I have a negative in front of a parenthesis. All right, that's a hidden -1. That needs to be rainbowed into the equation. So this becomes 6b minus 3b minus 8 equals 16. Combine like terms, 6b and negative 3b become 3b minus 8. And once again, we are down to two-step algebra. Add 8 to both sides. Divide by 3. So again, additionally, if I have variables on both sides, right, the whole point of algebra is getting variables, all the variables to one side, all the numbers to the other, and I can do multiple steps at a time, right? So I have variables and numbers. So I'm going to get the variables to the left side just because that's what we're most used to. So I'm going to subtract 8x from both sides. Now, that cancels this guy, right? Be aware, simultaneously, let's get the numbers to the other side so I can do these steps at the same time. And that cancels there. So notice, right? I have all the numbers, all right, on the right side, all the variables on the left side. 5x minus 8x gets me negative 3x equals 24 plus 12 gets me 36. And then, so notice that I basically did two-step algebra, but I did lots of steps at the same time. If you need to slow it down for yourself, that's absolutely fine. All right, just be aware, whatever is best for you. Then divide both sides by negative 3. That gets me x equals 36 divided by negative 3 is negative 12. Now, the idea is that be aware, I know I'm going through these kind of fast. It's because this should be a refresher. All right, if you need additional help with algebra, please let me know. But most of what I'm doing right here, this should be easier than the last algebra class you had. When you have lots of parentheses, always start with the deepest nested parentheses. So notice I have two sets of parentheses here on the left side. I'm going to start with the deepest set. So I need to rainbow that negative 4, and notice it's the whole piece. Similarly, on the right side, I only have one set of parentheses, so I'm going to rainbow that negative 4 as well. All right, so notice I'm not messing, right, with that 3 or that 2. Okay, you start on the inside because each time you say PEMDAS, parenthesis, da da da, oh, do parentheses. Then you say parenthesis again. You do the deeper parenthesis. So negative 4 times x. Negative 4 times negative 1. Then on the right side, 3, negative 4x minus 8. So that I'm rainbowing piece at a time. Also notice, as I rainbow, I drop my parentheses. All right, that's the whole point. That as you rainbow, you slowly eliminate your parentheses. Before I want to rainbow again, because I clearly see that 3 needs to be rainbowed in on the left side. Simplify, all right? Simplify your work. I can bring that 3 through at the moment, but it's way better if I simplify first and then rainbow again. Similarly, all right, I'm going to simplify on the right side. Now I'm ready to rainbow again, and I'm going to take that 3 in. Now let's bring the x's to one side and the numbers to the other. So I'm going to add 4x to both sides, and simultaneously I'm going to subtract 18 from both sides. Again, the 4x's cancel there, the 18's cancel there. That leaves us with negative 8x on the left side and negative 23 on the right side. Divide both sides by negative 8. And that gives us 23/8. Now, you can write that as a decimal. All right, you can write that as a mixed number. It's whatever is easier for you. All right, it's also based on with activities and home fun, it'll be based on what is asked for. Okay, I'm perfectly fine with you leaving it as the improper fraction there. It's less work to simplify that. All right. Uh, Ratio compares quantities by division. A ratio compares quantities by division. All right, that is a group contains 60 females and 30 males, right? Ratio of females to males would be 30, all right, divided by 60. All right, that reduces to 2 divided by 1. When we write that, we like this colon notation, 2 to 1, right? That's how that's read. All right, the division is just kind of initially, right, how you have a fraction written. All right, but we much prefer this colon type of notation. Proportions, all right, when you set up multiple fractions equivalent to each other. And then if you recall, cross multiplication, all right, you multiply across. This only works when you have an equality in the way. A times D, right, multiplies by C times B, and you can then set those equal and solve that down. So cross multiplication is the fast way to solve ratios. So if I have 25 to 8, which equals x to 2. Now be aware, this is often written like this. This is a super common question on the HESI right here. All right, just for anyone who's in health science. This, all right, breaks down a single colon, as we just discussed, means turn that into a fraction. 25 divided by 8. Double colon, all right, means that is an equal sign. And then again, single colon is a fraction. Once you have it written like this, then this is pretty easy. Cross multiply and solve this down. 25 times 2 equals 8 times x. And then we can solve that down. 50 equals 8x. /58, which gives us 25/4. And again, you can leave it like that, or you can turn it into the decimal, which is 6 1/4. All right, similarly, I have a ratio, cross multiply, 22 times x equals, all right, 2 times 60 minus x. I'm going to write that out because once again, we need to rainbow. Rainbow is everything. Distribute. And then I can solve that down. $24x equals 120. Divide by 24. Which gives us 5. All right. Now again, just practicing, right? Ratios, that's all that was. Now we need to see if we can apply it. Wildlife biologists catch, tag, and then release 135 deer back into a wildlife refugee. 2 weeks later, they observe a sample of 140 deer, 30 of which are tagged. Assume the ratio of tagged deer in the sample holds for all deer in the refuge. Approximately how many deer are in the refuge? So, all right, if we have, right, 135 deer out of basically whatever that overall total would be, that's the number. I'm going to set this up as tagged deer. Okay, so if we have 135 deer, which were tagged, out of the total number of deer, then, right, we observed 140 deer. 30 are tagged. So basically, right, we are setting it up as tagged divided by total. And it doesn't matter how you do it. All right, so I could set it up like that, or I could set it up as 135 tagged, and then later we saw 30 tagged. That's set up to an unknown number to 140. Both of these, all right, are the same because they will both work out when you cross multiply. So this one, just so you know, tagged out of total equals tag out of total. This one I'm setting up as tag divided by tag equals total divided by total. Now, be aware that I like this first method because 30 tagged out of 140. This one, you have to make sure that these numbers line up. So you have to line them up, all right, that the 30 tagged and the 140 are both in the denominators. Regardless, once you're there, we can cross multiply 30 times x and 140 times 135 and then divide by 30. So basically that means our count is 630 total deer. And, all right, that's how we can use proportions, all right, in context. As with everything, all right, applications are the best part. So we looked at some basic algebra, basic proportions, but application, that's where the problems are the most interesting. So let's look at some examples. Oreos reduced fat cookies contain 35 calories of fat in each serving. This is 40% less than the fat content in each serving of regular Oreos. How many calories of fat are in a serving of regular Oreo cookies? Couple of tricks here. First, 40%. Percentages in general. Remember, we have to deal with percentages by actually using decimals. The other trick here is percentages are kind of tricky. 40% less. Okay, that doesn't mean subtract in the traditional thing, right? When I say $10 less, I would subtract. But when I say 40% less, that actually still means, all right, that I'm going to be dealing with multiplication. But when I'm talking about the less, 40% less, it's always to 100. 100%, 40% less than that is actually 60%. Because what we're actually dealing with, 40% less means 60% of the total. And if we were trying to identify, right, there are 35 calories of fat, right, in reduced Oreo cookies. That's 40% less than how much is in a regular Oreo cookie. Fat cal in reg Oreos. So, all right, that means that we actually are doing 0.6 times some unknown value equals 35, and then you divide. Percentages, all right, you only subtract when it's percentages among percentages, but when you have percentages and values, it's always going to be multiplication and division. Which gives us x equals 58.33 calories. And I guess let's be specific. Fat calories. All right, context is everything. Also want to emphasize that even when problems look long, don't panic. The biggest thing I see is when there's word problems, everyone just gives up. Well, you can't do that in this class. This is problem solving. Everything we do in here, all right, is a word problem. So read it one piece at a time, identify your information, pull it out. While planning your vacation, you find out that you will need to cross a toll bridge. One payment option requires purchasing a transponder for $20. Okay, so already I see I have multiple payment option or multiple options here. So let's call this guy option one. Purchasing a transponder for $20. When you purchase the transponder for $20, all right, you will pay a reduced toll of $3.25 each time you cross the bridge. Okay, so it's going to be dollars. Another option, toll by plate. You pay the full toll, 4.25 each time you cross the bridge, plus a $3 administrative fee for each crossing. Okay, so already I see X equals number of bridge crossings. So this guy was 325X, and this, all right, is 4.25X plus 3X, all right, because each of those is for each fee. Find the number of times you would need to cross the bridge for the two options to be the same, all right? So basically, we're trying to identify when they're the same, which means I'm setting them equal. And oh, look at that. Basically, I just have a simple equation that now I need to solve. It's all about identifying my information, right? I found my variable, I set up my equations, okay? That also reminds me, this is a problem I see constantly where I see people doing stuff like this, right? They go through and they highlight. Now, that can be useful to a degree, but all of a sudden, when I start seeing people, right, highlighting has a real issue that people just get out of control with the highlighting until everything, all right, is lit up. That's why I like to identify information instead of just highlight it all. And I highly recommend that strategy for you. If you use highlighting, just use it carefully. Okay, so once we have that, let's simplify our equation down a little bit more since we were just identifying it. And that becomes 7.25x. This actually is a pretty simple solve, which is also my point. Because initially, everyone just panics over how possibly difficult a word problem could be when it actually is not too tough at all. So x equals 5 bridge crossings. All right. A new car worth $25,000 is depreciating in value by $3,000 per year. After how many years will the car's value be $9,000? So we have a car started out at $24,000. Depreciating means decreasing, right? So subtract $3,000, where this time we're going to call X equals years. And after how many car years will the car be worth $9,000? Once again, all right. Simple equation to set up. Solve it down piece by piece. So once again, look at that. X equals 5, but now 5 years. So solving our problems, all right, piece by piece. All right, take your time. Don't panic. All right, so one other big application, all right, with algebra, all right, is using equations with inequalities, because way often we speak as by saying, we don't say, oh, when is this going to be exactly equal to this? When is this exactly equal to this number? We talk about things, when is it going to be at least this, at most this, right? Right? I will retire when I have at least $1 million, right? I don't say, oh, when I have exactly $1 million. We tend to speak in terms of inequalities. So couple of things. All right. Notation. All right. open interval. All right. Notice strict inequalities. A, so I have a number A and I have a number B. When we draw this, all right, when you have strict inequalities, we draw them with an open circle. Open circle to an open circle. That means excluding the point. If you have a less than or equal to, greater than or equal to, all right, with the line underneath, that means including that value. That means, right, so my value B. Same thing, all right? If I have B, I have a value A and a value B. A is excluding, but B is including. That means I have up to and including B. We draw that with a closed circle. Similarly, now I'm including A, all right, closed circle, up to B excluding, all right, notice strict, all right, means excluding that value, not including it, all right, with the line underneath, that means including that value, that value and more, not just more. And similarly, if I have the value A and the value B, I am including, closed circle, both those values. Let's look at some examples. So I want to graph x less than or equal to 7. So when you actually draw a number line, you don't have to put all the values on there. Most importantly, you put 0 and then put the numbers you're interested in that relate to the problem. In this case, 7. 7 on a number line would be above 0. So that's the important part. And notice that when I was drawing them, I draw it on top of, not on. Because unless you are actually using different colors, it is impossible to tell. So do not draw your intervals exactly on the number line you just drew. I can't tell, right? And really, neither can you. So I have the value 7, and notice x is less than or equal to 7. That means I am at 7 and including that number, so I'm going to draw the closed circle. X, all right, is then below 7. So we draw that as everything below that. Now, if you always write it with the variable on the left side, the little trick is that the inequality, right, the alligator mouth will actually be pointing the direction, right? Notice that's pointing to the left. Oh, look, that's exactly what we had right there. It's pointing to the left. Now, that only works if the variable is always on the left side. So don't get fooled by that. I want to graph -5 less than or equal to x less than or equal to less than 2. So once again, I'm going to put the value 0. -5 is below that, and 2 is above that. And notice it looks exactly the same distance. It's because my numbers indicate. At -5, I am including that value, closed circle. At 2, excluding. And basically we have a line that connects the two. Solving equations with inequality is basically the same as the algebra we looked at before. The difference, all right, will be that when you multiply or divide by a negative number with an inequality, you have to flip the direction of that inequality. Otherwise, it is exactly the same. So let's solve and graph the equation here. So I'm going to move the x's to one side and the numbers to the other. So 2x minus x. All right, notice the 4's cancel and the x's cancel there. 2x minus x gives me an x on that side. This inequality does not change. It remains. It was less than or equal to 4. It remains. 1 minus 4 is -3. Then we can graph that. Again, 0. Put the value -3. I have less than or equal to. Which means that is a closed circle. And x is less than or equal, which means that goes to the left. And notice again, right, that's what I was talking about. Oh, look, that's pointing the same direction. 8y plus 1 less than 17. All right, so minus 1. Divide by 8. Also, be aware, you can't graph this, okay? This is nothing. I can't graph it until it is solved. You have to wait until you get this down, all right, to an actual equation, right? Y, quote, equals 2, all right? So make sure that you wait until you solve it before you attempt to graph it. Way too often I see people trying to graph, all right, 8y plus 1 less than 17. I don't know what that looks like. 17, 1, and 8 are not on, have nothing to do with what we're about to graph, right? Okay, so 0 and 2, and it's a strict inequality, which means open circle. And once again, oh, look, less than to the left. Negative 16x less than or equal, all right, to negative 64. This is the case that I was talking about. So first, I'm going to solve this with only adding and subtracting. So I'm going to add 64 to both sides. And I know I'm going to do this the real slow way. It's going to be painful for just a minute. Plus 16x to both sides. And then divide by 16. Okay, so I got x. Now be aware, notice the x is on the right side. You can flip this. This becomes x greater than or equal to 4. So it's important to understand, all right, that the inequality will change directions if you move the variable now. It's not like inequalities. So that's the long way to do it. We had negative 16x less than or equal to negative 64. I can do this in one step. Divide both sides by negative 16. On the left side, I get x. On the right side, I get a 4. Because I divided by a negative number, that means the inequality has to change direction. So it was, all right, a less than or equal to. Notice it changes to a greater than or equal to. It is important that you understand that. That's the only difference between solving with inequalities and solving with equalities. Once I have that, though, the graphing is the same. 0, 4. I'm going to put a closed circle since I have a greater than or equal to, and then it goes to the right. Again, notice that when the variable is written on the left side, x greater than or equal to 4, the alligator mouth, right, the small side of the alligator mouth points the direction. It is super important that you make sure you're always facing the correct direction, because way too often, if you leave it written in this form here, it doesn't work. As with everything, the best part is applications. All right, so let's look at a couple of application problems. The average price of a movie ticket can be estimated by the equation P equals 0.1522y minus 298.592, where y is the year and P is average price in dollars. For what years will the average price of a movie ticket be at least $6? So notice the wording there, at least. So we have that equation, right? Price of a movie ticket is at least greater than or equal to 6. That's how we tend to speak. And so that's what this equality is going to look like. All right. I have then, all right, my equation that was given above, 522y minus 298.592 greater than or equal to 6. And then it's just solving an equation like any other equation. And again, the numbers aren't great, but with real world applications, the numbers tend not to be great. Divide by 0.1522. All right, so that gives us y greater than or equal to 2001.26. Inequalities, even more so than equality equations, really require a sentence statement because you need to make sure that you include this terminology, the at least, at most, more, less, all right, in your interpretation. So, movie ticket prices will be at least $6 from 3 months into 2001 and on. All right. 3 months, right? Which is a quarter, right? So 12 months, right? I was just doing 12 times a quarter. 3 months into 2001 and on, and the movie price tickets will be at least $6. It's that at least wording. That's the big thing we need to make sure we focus on. Another example. Scott's Electric Company made 17 customer calls last week, 22 calls this week. How many calls must be made next week in order to maintain an average of at least, all right, 20 calls for the 3-week period? Again, super important to make sure you're paying attention to that at least, at most, all right? Minimum, maximum type of wording. All right, so let's recall what an average is. An average, right? Represented notationally, usually as something like X bar. All right, it is the sum of the values divided by the total number. In this case, I have calls, 17 calls last week, 22 calls this week, some number of calls next week. Let's call that C, divided by a 3-week period. And then if we have at least 20 calls, that means, all right, that number is at least 20. Then, all right, again, setting up is the big part. Solving this then is a matter of just simplifying this down. Now, algebra, multiply both sides by 3/1. And 17 plus 22 is 39. The 3's cancel out. Whoops. 21. So it's just called the company. Oh, the electric company. The electric company must make at least 21 calls next week to maintain their 20 call average. Again, the big part, it's all about that at least, at most, greater than, less than, maximum, minimum, wording. All right. These are the biggest ones where you want to have a sentence, all right, at the end. All right. Another wonderful lecture. We will call it a day for there. Have a great day.